Hey Python lovers, welcome back to my channel, and today we're going to build something amazing together, our very own calculator app. But here's the thing, we're going to understand every single line, why we write it, and how it works. By the end of this video, you'll not only have a gorgeous calculator, but you'll actually understand what makes it tick. So grab your favorite beverage, open up your Python editor, and let's dive into the wonderful world of GUI programming. Trust me, this is going to be fun. First things first, let's set up our workspace. Go ahead and create a new folder and give it a name that fits your project, something like Calculator App or any name you like. Open newly created folder with VS Code. Create a new file and name it calc.py. This will be our calculator program. All right, friends, our very first step is to understand what we're working with. We're going to use something called Tkinter. And let me tell you why this little library is absolutely incredible. Think of Tkinter as your GUI superhero. GUI stands for Graphical User Interface, basically all the buttons, windows, and pretty visual stuff you click on. Without GUI, we'd all be typing commands in boring black terminals forever. Why Tkinter is so awesome? It's because comes built into Python, no extra downloads, works on Windows, Mac, and Linux. Perfect for learning GUI concepts, won't slow down your computer, been around for decades, super reliable. Now let's import our superhero. Import Tkinter as TK. See that as TK? That's like giving Tkinter a nickname. Instead of typing Tkinter every time, we just type TK. It's like calling your friend Mike instead of Michael, much easier. Type this line and run it. If you don't get any errors, congratulations. Tkinter is ready to rock. Now comes the magical moment. Creating our first window. Think of this as buying your first piece of digital real estate. This window will be the home where all our calculator buttons live. Let me explain what just happened. tk.tk is like calling a construction company and saying, "Hey, build me a window." The parentheses are like dialing their phone number. Pretty cool, right? But wait, our window needs a name. Let's give it a title. Calculator window.title, and inside parentheses bracket, write your calculator name. This is like putting a nameplate on your front door. Now here's the most important part. We need to tell our window to stay open and wait for us to interact with it. For this, we will use main loop function. This main loop is like hiring a security guard for your window. It says, stay open, keep watching for button clicks, don't close until I tell you to. Without this line, your window would appear for a split second and then poof, disappear. Let's see our complete code. So now, to run this code, you'll need Python installed on your computer. If you don't have it yet, I've included a full installation guide. The link is in the description. All right, once Python is installed, here's how to run the app. First, open the terminal. You can do this from the terminal menu by clicking New Terminal or press Control plus the backtick key, usually above the tab. With the terminal open, type Python and your filename .py, in our case, calc.py, and press Enter. Run this code and boom, you've just created your first GUI window. You can resize because it might look empty and boring right now, but trust me, we're going to make it absolutely gorgeous. Every calculator needs a screen or a display. This is like the face of our calculator. It's where all the numbers and results will appear. We're going to use something called an entry widget. Why entry? Because it's where we can enter text. Makes sense, right? Now let's name our screen Display Screen. We will set it up as tk.entry. Inside the parentheses, we write calculator window. Why? Because our screen needs to sit on the calculator window. That's called setting the parent. It's kind of like saying this display belongs inside this window. In our case, adding the parent is optional, but it's a good habit to keep it there. But hold on, we can make this display screen much cooler. Let's customize it. We can set the width of our screen using the width option. And remember, this is measured in characters, not pixels. We can also choose the font and its size. If we want to align the text, we use the justify option. To control how thick the border looks, we use border width. And finally, to change the style of that border, we use relief. Now we need to tell our display where to sit in the window. This is where the magic of grid comes in. Let me break this down. It's like giving GPS coordinates to our display. First, we will write displayscreen.grid. Inside the parentheses, we set a few options. Row equals 0, which means sit in the very first row at the top of the window. Column equals 0, start in the very first column on the left side. Column span equals 4, stretch across 4 columns so the screen takes up more space. Pad X equals 5 and pad Y equals 5. Add a little padding or breathing room around the display. Run this code and you'll see your calculator now has a beautiful display screen. You can even click in it and type, "Try it." Before moving forward, let's add some padding on our window. We can add padding using configure on our calculator window. So inside configure, write pad X equals 20 and pad Y equals 20. You can see it's now better and doesn't touching the corner in any cases. Now for the fun part, creating our first button. This is where our calculator comes to life and starts responding to us. Buttons are like the hands of our calculator. They let us interact with it. Let's create our first number button, the number 1. To place a button inside our calculator window, we'll use tk.button. We assign its parent to calculator window, so the button knows where it belongs. Then we set the text to display on the button, for example, the number 1. And finally, we give this button a name in our code so we can refer to it later. To display this button in our calculator window, we need to place it inside a grid. Just like we did earlier for the display screen, we'll do the same for the button as well. We'll position this button at row equals 1, column equals 0, and add a padding of 2. Since the first row, row 0, is already occupied by the display screen, we're placing the button in the next row. Now, what happens when someone clicks this button? Right now, absolutely nothing. We need to teach our button what to do when it gets clicked. This is where functions come to the rescue. Think of a function like training a pet. We're going to train our button. When someone clicks you, do this specific thing. So let's define a function name button underscore clicked. Inside this function, we'll tell our display screen to show the number 1. We do this by inserting 1 at the end of the text in the display screen. Here, def means I'm about to define a function. Button clicked is the name we gave our function. The tk.end part tells Tkinter to add the text at the very end of the display. And insert will insert the text in the display screen that we have defined above. Now we connect our button to this function by using command equals and setting it to the function we just created, button underscore clicked. Run this code and click that button. Watch the magic happen. You should see the number 1 appear on your display screen. Congratulations, you just created your first interactive GUI element. Now here's where we level up our programming skills. Right now, our function only handles the number 1, but what if we want buttons for 2, 3, 4, and all the other numbers? We could write 10 different functions. Or we could be smart about it. Let me introduce you to one of Python's coolest features, the Lambda function. Think of Lambda as a quick one-line function. It's like the difference between writing a full letter versus sending a quick text message. To achieve this, first we'll add a parameter called button underscore text to our button clicked function. This way, we can pass any value from the button into the function whenever it's clicked. Next, we'll update the hard-coded value inside the function and replace it with button text. Now our function can handle any button text we give it. But here's the problem. How do we tell the button which text to send to our function? Well, we can pass it by using Lambda superhero. Make this change in our command. This Lambda is like a messenger. When the button gets clicked, Lambda runs to our function and says, "Hey, someone clicked the button with 1 on it." Run the program and test it. Excellent. It's working. Now we can make our buttons even cooler by decorating them. Just like our display screen, we can adjust the width, height, and font to make them look nice and stylish. If you want, you can also change the button's background color when it's clicked by using the active background property and setting it to any color you like. Creating all the buttons manually takes a lot of time. So instead, we'll define a multi-dimensional array called calculator buttons, where we list all the buttons we'll use in our calculator. In this array, each row and column represents the position of a button on the calculator. Next, we'll use a for loop to create all the buttons automatically. First, we loop through the rows using for row number, buttons, corner row in enumerate, calculator buttons. Then inside that, we loop through each column using for column number, button text in enumerate, button row. Here, enumerate helps us get both the position and the value at the same time, so we know exactly where to place each button. Now we'll place our button and its grid inside the loop. Since the buttons are created dynamically, we'll give the button a meaningful name, like calculator button. The text on the button will come from button text. Similarly, for the grid, we'll use the loop variables row number and column number, which automatically handle the position of each button. And we'll also update the command to use this variable. Now, run the program and take a look. Beautiful. Look at that beauty. You can see the math expression building up on the display. We're so close to having a fully working calculator. Since we're focusing on the basic concepts of GUI, we won't dive into controlling or restricting multiple operators just yet, as that would make this video longer. We'll cover those topics in upcoming videos. For now, we'll stick to the very basics. This is it, folks. The moment we've all been waiting for. The equals button, where all the magic happens. This button will take whatever math expression we've typed and actually calculate it. Here's the beautiful thing about Python. There's a built-in function called eval that can evaluate math expressions for us. It's like having a tiny mathematician living inside our calculator. But wait, we need to be smart about this. What if someone types something wrong? What if they divide by 0? We need to handle errors gracefully. This is called defensive programming. Always expect the unexpected. Let's have a fun. First, we will get whatever is currently shown on the display and store it to current display. We can get the text from our display screen using get function. Next, when someone presses the equal sign, we'll use a try except block. Inside the try part, we calculate the result using eval and store it in calculation result. Then, we clear the display screen using delete and insert our result back as a string using steer, because the display expects text. Isn't that cool? In the except part, if something unexpected happens or there's an error in the calculation, we clear the display and show the text error. We also have another button, clear. If the user presses that, we simply clear the display screen. Finally, in the else part, meaning if any number or operational button is pressed, we insert that text at the end of the display. Now, let's run the program and check it out. Test time. Try these calculations or your own. 5 plus 3 should give 8. 10 over 2 should give 20. 100 over 4 should give 25. And try to break it. Type something wrong, you should see our friendly error message instead of the program crashing. Look at what we've created. This isn't just a calculator, it's a professional application with smart error handling, beautiful visual feedback, and professional styling. We started with absolutely nothing, just a blank Python file. And now we have a professional calculator application that would make any programmer proud. Let me know in the comments what you want to learn next. And yes, everything will be in Python. You won't want to miss it, so make sure to like and subscribe. Remember, every expert started as a beginner. You took that first step today, and I'm really proud of you. Keep coding, keep learning, and keep creating amazing things. Until next time, happy coding, Python Warriors.